Hey there, science educators. Welcome. My name's Kate, and I'm from Inner Orbit. I'm super excited that you decided to join us today for this first in a series of videos about revising assessment items for better 3D NGSS alignment. In this video, working backwards to move students forward, I'm going to demonstrate how you can revise existing questions to improve their alignment to all three dimensions of the NGSS. Our goals for today are: first, we're going to quickly review the three dimensions of the Next Gen Science standards. You might also hear me refer to these as performance expectations, or PEs. Then we're going to break down each of these PEs into bite-sized pieces that we can use to guide our revision of some of our existing questions. Then we'll work backwards from those bite-sized three-dimensional pieces to create a truly tightly aligned three-dimensional assessment item. And finally, we'll use a color coding strategy to check our work. We can use this on really any question or assessment item that we already have in our toolkit to make sure that it's truly aligned and three-dimensional. If you're ready, let's get started with working backwards to move students forward. Let's take just a moment to review the three dimensions of the Next Gen Science standards. Each NGSS standard, also called a PE, is a three-dimensional statement that describes what students should be able to do. The three dimensions in no particular order are the DCIs, or the disciplinary core ideas. This is the content or the what students need to know, and this could be parts of a cell, patterns of weather and climate, or Newton's laws of motion. The science and engineering practices are what students do to engage with that DCI content. The way that might look in a classroom is students interpreting data, analyzing graphs, or creating and using models. And then there are the CCCs, the third dimension. This is how students think about the content. At Inner Orbit, we often refer to these CCCs as the lenses through which students examine content to make sense of the world across all of the different domains of science. CCCs might look like identifying patterns or determining cause and effect relationships. When students interact with all three dimensions, they're able to engage in the process of sense-making, or explaining the how and why behind a phenomenon that they might be seeing for the first time. This is different from representation, which sees students communicating ideas that they previously learned and still remembered. While both sense-making and representation are important for learning, in this video, we're going to be working on taking items that may be focused on student representation and revising them to move students toward three-dimensional practice of sense-making. This is the true goal of Next Gen Science. Now, let's take our first step towards truly beginning to revise assessment items for better 3D alignment. Every performance expectation, PE or standard, is already broken down into three dimensions. So let's dig into how that breakdown can be simplified to drive these types of revisions. So, to do this, let's take a look at an actual high school performance expectation. This is HS High School LS Life Science 4-1. And this asks students to communicate scientific information, there's that SEP, that science and engineering practice, that common ancestry and biological evolution, there's our DCI knowledge, are supported by multiple lines of empirical evidence. This last bit ties both to the DCI and to the cross-cutting concept of observing patterns at multiple scales to help us study systems. So now, for us to begin writing or revising questions that truly engage students with all three dimensions of the Next Gen Science standards, we need to have something to write about, and students need to have something to make sense of. So let's select a phenomena. Darwin's finches seems pretty appropriate for this high school life science standard, and although it might be familiar to you, your students have likely never studied it. So, in order to give students a fair shot at answering questions about this phenomena, we'll provide them with some text, maybe a cool GIF or a video, perhaps a cladogram or some photographs that allow them to investigate what embryological versus anatomical structures look like. Now we can start writing questions and analyzing them to see if they are truly three-dimensional and promote sense-making. Now that we've broken down the standard into some bite-sized pieces and we've selected a phenomena, let's use a color coding strategy to analyze an existing question we might see on one of our assessments. Let's employ this color coding strategy to analyze a question that we might find on any high school biology exam. This question asks students, what different types of evidence help scientists determine evolutionary relationships and common ancestry when studying organisms? This is a great question, But let's break it down based on those bite-sized three-dimensional pieces that we just established to see if it truly engages students in the process of sense-making. And we're going to start with the SEP. Remember, the science and engineering practice for this standard was communicating information. And at first glance, it does seem that this question is asking students to communicate information. But there's a gap. Students are not being asked to use that information to make sense of this phenomena, Darwin's finches and their common ancestry. So I'm left sort of holding my highlighter here with nothing to highlight in this question that's truly tied to that science and engineering practice. Let's look for evidence of DCI knowledge. Are students being asked to use their content knowledge about common ancestry and evolution to answer this question? As we locate and color code this part of the prompt, we can see that they most certainly are. They're being asked to recall the different types of evidence that can support an understanding of common ancestry and evolution. So when it comes to DCI knowledge, this question truly hits the mark. Lastly, let's look for evidence of engagement with that CCC, that cross-cutting concept of patterns. Again, an initial look might make us want to highlight something here that's tied to patterns, those patterns of evolutionary relationships, but nothing is really prompting students to explain how these patterns might provide evidence for causality or help explain the phenomenon. So we have to say that although this is a great question, it's far more representational. It's asking students to remember and write down information that they learned in class. It's not truly 3D because it's not engaging students with each of those three dimensions to promote the process of sense making. So how do we fix it? Here's our opportunity to work backwards from the language of the performance expectation to build a question that is truly three-dimensional and promotes the sense-making process. We're going to do this by using a series of questions that are tied to each of the three dimensions of the PE. And again, we're going to start with the SEP, which asks students to communicate information about the phenomena. A question we can ask ourselves to help us revise and improve this question is, how do I want students to do that? Well, in most assessment formats, we're sort of limited to either writing or drawing, so to keep it simple, let's just prompt students to explain. But what do I want them to explain? So to hit on that DCI element, in this case, I want them to explain why multiple sources of evidence are important for establishing common ancestry among Darwin's finches. In other words, I want them to use their DCI knowledge as evidence for their explanation of this phenomenon. Finally, I have to consider, how am I going to prompt them to examine patterns on different scales to provide evidence for causality? And this one's a doozy, folks, for sure. But as often happens, when we begin to break down these PEs, we find a strong connection between the cross-cutting concept and the DCI. Here's what I mean. Micro or molecular scale patterns such as DNA and amino acid sequencing help us explain macro scale patterns like embryological and anatomical characteristics. Both are useful as we attempt to establish common ancestry, and we want students to use all of these to help make sense of the phenomenon of Darwin's finches. So now let's smash the results of our backwards planning together into a single prompt. And here's the question we come up with. It's pretty awesome. It's three-dimensional, but as a teacher, I might want to refine it a little bit based on what I know about my students and what I expect from them. So to increase the rigor of this question, I'm going to tweak it just a bit. And here I've removed explicit reference to the types of evidence we studied in class and included language that prompts them to discuss them. You know what's right for your students, and hopefully this process will be really, really helpful in helping you build questions that are right for them. In summary, we reviewed the three dimensions of the Next Generation Science Standards, or PEs, and then we broke down those PEs into bite-sized pieces that we can use to improve our existing questions and write new ones. Then we used a color coding strategy during which we can highlight where students are engaging with each of those three dimensions within a question. If they're not, we learned how to work backwards from the performance expectation language using a series of simple questions to help us create a fully aligned and three-dimensional question. You can find more aligned 3D questions on our site at innerorbit.com, and please click on the link if you'd like to know more. Thanks for joining us for Working Backwards to Move Students Forward, and we look forward to seeing you during our next video.